Yeah, good morning, students. In the previous classroom discussion topic, we just had a discussion on the basic terminology used in data structures course. And also we defined what is a data structure. Fine. Now in today's classroom discussion, we would like to discuss what are the important operations that we can perform on any data structure. Fine. So now I would like to share my screen. Hope my screen is visible to you. So this is week 1, lecture 2, operations on data structures. So summary of the previous classroom discussion topic is that in the previous class, we had a discussion on what is a data and what is an information. Information is nothing but processed data, and we have defined a data structure as a triplet, as D is the set of data objects and F is the set of functions which represents the operations, and A is the set of axioms which represents the rules to implement those operations, right? Now, in today's classroom discussion topic, we would like to discuss on operations and data structures. So this session will develop the students' knowledge on what are the operations that can be implemented on data structures. The outcome of this today's session is that after completion of this session, students will able to develop the code for implementation of various operations on data structures, right? So what are the important operations that we can do on data structures? Or this is foremost thing is traversing. So traversing is one important operation that we can do on any data structure. That is nothing but accessing of individual data items exactly once. That is what the traversing operation. Then next, which we can call it as second important operation is searching. So it is used for locating the given data item in the data structure. Find searching. For example, we have a set of students. We want to find the student who scored 100 marks in a particular subject. Then this is nothing but what we are calling it as a search operation. Fine. And another important operation is insertion. So it is used to add some new data item to the given list of data items in the data structure. So the insertion can be either at a given position you can add, or at the beginning you can add, or at the end of the data list you can add it. Then another important operation is deletion. It means we are trying to remove the data item from a particular collection of data items. For example, to delete the name of a student which left the course. Fine. So like that, deletion can also be done from front. You can do the deletion at the position, given position, or we can delete the element from the rear end of that data list. Then another important operation is sorting. Sorting is also another operation which we can perform on any data structure. So which is used for arranging of the data items in the data structure. We are arranging the data items either in ascending or descending order or alphabetical order. We are arranging those data items. And another important operation is merging. So merging is nothing but when we are given two sorted list of data items. So these two sorted list of data items are combined to form a single sorted list of data items. That is what we are calling it as a merging operation. Fine. So these are the important operations that we can perform on data structures. Now coming to these examples of various operations and data structure in real life, if you take that, so which type of data structure is used in a particular situation? If you are given a real life situation, for example, if you take we want to store the social network feeds. So we do not know the size and things may be dynamically added. Then which data structure is suitable for storing of these social networking feeds? So it may be either linked list or it may be a hash table is best suitable for that. Then next is second real life example here is that we need to store undo and redo operations in a word processor. That is when we are pressing Control Z, we are undoing, and Control Z for redoing operation. So which one is best suited is here is that stack is the data structure which can be best suited for implementing this operation. We will use two stacks for one is redo and another one is undo operation. Fine. Then if you take another third real life example is that we want to evaluate an expression. That is a parser will use this. Then stack or parse tree will be used here basically. Stack or a tree will be used here to evaluate that expression. And another fourth important application, real life application, is that we need to store the friendship information on a social networking sites. So which is a friend with whom, that information we want to store that. Then we are going to use make use of a graph data structure. We would like to use that. But getting the point here. So for example, if you want to store an image of size 1000 by 1000 pixels as a bitmap image, if you want to store that, then what data structure is used here? We can use a two-dimensional array. We can use that, fine, or array list in Java. We can use that. So like this here, based on some real life scenario or example. So for representing of that data pertaining to this real life scenario, which data structure is best suitable for that, fine. So to implement printer spoolers so that jobs can be printed in the order in which the print jobs are submitted to the printer. So there we are going to use queue. So to implement back functionality in the internet browser, when you are clicking a back button, you have to come back to the previous page which you have accessed in the internet. Then we are making use of a stack data structure. So to store possible moves in a chess game, so we are making use of a tree data structure. To store a set of fixed keywords which are referenced very frequently, then we are making use of a dynamic programming or a hash table. We are using that to store the customer order information in a drive in burger place. Customers keep on coming and they have to get their correct food at the payment or food collection window. So we can either use queue or we can use minimum priority queue. We can use that. So to store the genealogy information of biological species, so we are going to make use of a tree data structure. So like this, these are the different types of data structures which are used in storing of the data pertaining to this given real life situation. Right? Now coming to this reflections part, identify the operations performed on the data structures. Option A is insertion, B is traversing, C is searching, D is deletion, and E is sorting. Anyone? Yes. Any student can answer this question. Yes, all are the right options. So if you are not able to understand, then please refer to this video from the beginning. Watch the video from the beginning. So the lecture outcomes are revisited here. After completion of the session, students will be able to develop the code for implementation of various operations on the data structures. Right? Then summary of this today's session is that the following are the operations which we have defined on the data structures: traversing, searching, sorting, inserting, deleting, and merging. Fine. Then next we have identified the real life applications where the data structures are used. For example, so what type of data structure is suitable for storing of these social network feeds? So we have identified that it may be a linked list or hash table, because the feed may be the size of the tweet we don't know, and when it will be generated also we don't know, because it is dynamically generated, and we need to add dynamically. So we are making use of a linked list or an hash table. We are using that. So like that, for a given real life situation, which type of data structure is suitable, that we have identified that. Fine. Now coming to the lecture level practice problem, here we have given that identify the suitable data structure used in the following applications. Fine. So please go through this applications and try to identify it. The next, coming to this is further readings about this particular topic. So you can refer this textbook on Devasis Samantha, classic data structures, or other reference textbooks are there. Data structures using C by Rema Terecha we can use, or Balagiri Swami also we can use that. Okay. So thank you one and all.